parameters exponential smoothing method is an extension of simple exponential smoothing. It adds a growth factor or trend factor to the smoothing equation as a way of adjusting for the trend. It models suitable when a time series is increasing or decreasing approximately at a fixed rate. Double exponential smoothing method is given by double exponential smoothing method employs two smoothing constants denoted by alpha represent the smoothing constant for level and beta represent the smoothing constant for trend. Now, we are going to see some demonstration on how to model a data by using hot method in Excel.
Now, let's see a tutorial on double exponential smoothing model, or also known as hot method. This method is suitable when our data contain trend. To check whether our data has trend or not, you can simply draw a graph. To draw a graph, we can highlight our data, click Insert, click Recommended Chart, choose a plot that is suitable with our data, click OK. So as you can see from this plot, our data contain an increasing trend. So that means we can use this model to fit our data. The formula of this model is given by this equation. Since the name of this model also double exponential smoothing, that means we have two parameters in this model. The first parameter is the alpha. The alpha is for the level estimate. Second parameter is given by the beta. Beta is a smoothing constant for the trend. Just like the single exponential smoothing model, we will also use this formula of LT and BT to calculate the parameter in Excel. I will show you after this on how we can do this formula by using Excel. If we refer to the formula of the LT and BT, you can see that they use LT minus 1 and BT minus 1 in the formula. So that means, if let's say our data start from 2000, we have to create another cell that show the year of 1999. To do that, we can simply click the cell, click Insert. So you will write here the year of 1999 where the time is equal to 0. The amount YT will be left blank because we don't have any data from that year. Similar to single exponential smoothing model, we will use the equation of Ft plus M equal to Lt plus MBT into the Excel. So that means we need to have a column of Lt and BT and another column for Ft. Before we start calculating the Ft, let's see the procedure on how we can do the forecast. In step 1, obtain initial estimate L0 and B0 by set L0 equal to Y1 and B0 by using these three methods. So you can choose either you want to do B0 equal to Y2 minus Y1, or B0 equal to Y4 minus Y1 divided by 3, or B0 equal to 0. So L0 here will be equal to Y1. So this is Y1. Click Enter. And for the B0, I will use the first method, Y2 minus Y1. I click the cell, Y2 minus Y1. Click Enter. So that one will be my B0. Now we move to the second step. Calculate a point forecast of Y1 from time t equal to 1. So this will be our F1. Formula for F1 is L0 plus B0. So go to the cell, go to the formula bar, equal sign, L0 plus B0. Click enter. So starting from the step 3, we will update the estimate of LT and BT by using the formula of level estimate and trend estimate. So in this cell, after the L0 and B0, we will start using the formula that involve the alpha and beta. So we know that we can change the value of alpha and beta. Just like the single exponential smoothing, choose a cell where you will use the alpha and beta value as the estimator. So let's say I put this cell as the alpha, okay, and start the value of the alpha as 0.3. And here is the beta, and I also start the value of the beta as 0.3. So and then we will start calculate the LT for L1. So by using the formula LT equal to alpha YT plus 1 minus alpha LT minus 1 plus PT minus 1, I will get the value of the L1. So by clicking the formula bar, okay, equal sign, click the value of the alpha, multiply with the YT will be the Y1 plus open bracket 1 minus alpha close bracket multiply with open bracket LT minus 1 is the L0 plus PT minus 1 is the B0 here. Close bracket and click enter. And then for the BT means we will calculate for the B1 by using the formula. Click the formula bar, equal sign, the beta is 0.3, multiply with open bracket LT minus 1 means the L1 minus L0 close bracket plus with open bracket 1 minus beta, 1 minus click beta, close bracket and multiply with BT minus 1 means B0 and click enter. So now we have the value of L1 and B1. So remember, when we will use the same formula with a value that is not changed when we drag, so we put the $sign. So in this case, the alpha and beta value will always be the same. So we will put the alpha and beta with $sign. So I put it here. For every alpha and beta. Enter. And do the same for B. So this is the value of the beta. Click enter. Now we can drag this until the end of the data. Okay, now when we already have the value of the L and B, we can calculate the forecast. Okay, so the formula of the forecast is basically this FT plus M. Okay, M is the M step ahead forecast. So that means in our case, we calculate 1 step ahead forecast. So that means our M is equal to 1. Right? So we will apply this formula to calculate the forecast. So at the column of FT, okay, since you already have the value of the F1, so for F2, our formula will be, if FT plus M means if T plus M is 2, that means this is F1 plus 1. So equal to, the T is 1, so L1 plus M is 1, 1 multiply with B1. So click the cell, go to the formula bar, click equal sign. So our L1 is here. Plus, since the M is 1, we don't have to write down the 1. Plus, straight away go to the B1. Then click enter. So this is our F2. You can straight away drag this to get all other value of the F3. Okay, now after we have the focus, to find the best combination of alpha and beta, we need to have the sum square error value. So to get the sum square error value, same as the single exponential smoothing step, we will calculate the square error. So beside the FT column, go to the first value. So click the cell, go to the formula bar, equal sign, and then open bracket. Take the original value, which is the YT, minus with the focus value, close bracket, and then put square sign. Click enter. So this is our square error for the first focus. And then we can just drag this until the end of the cell, and you will get all the square error for each focus. Now go to the last column of the square error column, click the cell, equal sign, write down sum, click the sum from the Excel, and just highlight this cell, close bracket, and click enter. So there we have the sum square error. To find the best combination of alpha and beta, so we want to minimize the SSE. To minimize this, remember, we go to Data tab, choose Solver, and then Set Objective. We want to minimize the value of SSE. So in this table, click this. Go to Min. By changing the variable cell of alpha and beta. Subject constraint. The constraint is that the value of alpha beta is set to have between 0 and 1. So we add here. Cell reference for both must be less than or equal to 1. I prefer to use less than or equal to 1. And another one is for this cell to be larger than or equal to 0.01. Okay, as long as it is larger than 0, click OK. So you can see that there are two constraints for the parameters. And then this one you can try with other method, but I choose to stick with the GRG nonlinear. And then click solve. So we will keep the solver solution. Okay, so click OK. And you can see that to get the smallest value of SSE, the optimum value of alpha and beta should be 0.6 and 0.7. So this is the best alpha and beta to get the smallest SSE. So with that, we can write down that the best alpha and beta for this model is 0.6 and 0.9. So that's all for Hall method. So I hope you try to do this analysis again by using different B0 method and see whether you get the same focus or different focus. And if let's say it is different, is the difference large or small? So I hope to see you guys in the next tutorial where we will discuss about hot winter analysis. Bye!